Welcome to the third video on JawsJS. Now I'm starting again with the index.html file, just as a quick review using the canvas element, and it has a set width and a set height, 500 pixels. Moving over to the game.js file, we see there's a couple of new variables: viewport, max height, coins, and C. For coins and C, coins is what goal list was in the previous video, and C is what field was. But I'll go over it as I get to it within this file. Now a viewport, which is the emphasis of this video, is a view into a portion of a larger canvas. The canvas element within index.html was set to a very specific dimension, 500 by 500. If we want to make a game world bigger than that, we can use something called a viewport to extend the virtual canvas and allow it to be centered on a character or sprite as it moves within that area. And that's what a viewport allows us to do. You can think of it as a view into a portion of a larger canvas. So we've set it here to 500 by 800. Jaws that width by max height. Max height being set here, up here. And that states that whatever is within the viewport can't exceed those upper X and upper Y, the max X and max Y. Moving on to the player properties, we see it hasn't really changed that much since the last video. But instead of using a color and a width and a height, we're just using an image and a position, an X and a Y. If we use an image property of a sprite, we don't need to set the width and the height because that will be set when the image is created for the sprite. In this case, we're using squid, which is a little image I've made, which is over in images. Looks like that. It's a green squid I put together. And then we see moving into the move function of player that instead of checking the conditionals, if it's less than 0 left and up, or if it's greater than the width on the right or greater than the height on the bottom, we can now use this functionality as part of the viewport to force the player inside by a certain amount of pixel bars, in this case 32 pixels. This will make sure that the player is constantly inside the viewport, that it can't really escape. And that when it comes within the edge of it, that it will stop it within 32 pixels in. Moving down to coins, which is what goal list was in the previous video, we see it hasn't really changed that much. We're doing a few more loops from 1 to 10, so 9 this time. And we're using the coin image. This image right here. Sort of looks like a coin. And it's doing the same thing goal list was in the previous video. We're checking to see if it's colliding with player. Collide one with many, player with coins. And then the first result of that collision test is getting removed from the coin list. Coins removed, and then the first result, 0 index results. C is what field was, as I mentioned before. But this time I'm not using a named color like a blue or an orange. I'm actually using a hexadecimal representation, which is what the color allows us to do. We can use a named color, or we can use a hexadecimal representation, what this is right here. Or we can even use, what I'll cover in a later video, gradients, a radial or a linear gradient as well. Moving down to update, we see the main work of viewport, the center around function. Whatever we put in center around as an argument to that function, the viewport will center around it. As it moves, the viewport will move too, or will appear to move, showing only that the player, in this case, is at the center of it. Then we see the 4 conditionals we've been using, up, left, down, and right. And now we see a gravity. This is where dx and dy come into play. We can change slightly the dx or dy, the amount of change each game loop, to affect things like a wind or gravity. In this case, I'm using a gravity. We're adding 1 each game loop. So the sprite, without us actually touching any keys, will slowly move down the page, getting a +1 to its y each move. And then we see as part of the update that we're doing player move and coins check, as we went over in the last video. Now if we use a viewport, we want to make sure that the sprites we have, the objects we're using, are actually drawn within it. So we use those as arguments to the viewport draw function. And we do them in the same order that we had them in the last video, which was field player goal list. This time it's C player coins, being drawn in order in the viewport. Viewports come into use most often, as I mentioned, when you have a very large canvas, a sort of a virtual canvas that is larger than the physical canvas of the element in the index.html file. The useful thing about viewports is if a sprite isn't within the current view that's centered around the player in our case, then it won't get drawn. So if you have a large number of items, say hundreds of sprites or even thousands of them potentially, you can use viewport to cull them so you're only looking at a portion of them each time. Now coming down here to the onload function of JAWS, we see a new line, the assets.add. If we're using images or sounds or even video, we want to make sure that they're added to the assets, the sort of internal cache, the collection assets we're going to be using each time. In this case we're using coin and we're using squid. So we feed those as part of an array to the add function. We let them load it all during the initial loading phase. Notice it comes before we actually start play state. This allows us to load whatever we're going to use all at once. We can do an initial loading period where the loading bar moves from left to right and take care of all the loading all at once. So when the player gets to the actual play state, the start, they won't have to sit and wait for anything else to load. It will be taken care of all at once. So if we use images or sounds or video, we want to make sure we add them beforehand. They get added to the assets, and then our playstate actually starts. So when these are called later, in this case for player and then later for the coins, they're already loaded. And JAWS will look to see if it's loaded that. If it has, it will use the image it's already created from its cache and not create a new one. So no more loading times are added. So I've talked a lot so far. Let's actually look at it. So as we see, our squid slowly moves down the page as the gravity is affected. And as we move outside of the initial 500 by 500 area, it scrolls because the viewport is longer than an actual canvas element. Canvas element is 500, but our viewport is 500 by 800, so we scroll the extra 300 pixels down. And you notice if I press the arrow keys, I can also scroll. As I move up and sort of float around on the background of C. And I can also, as I did in the previous videos, collide with the coins, and we pick them up, one by one, as we slowly float down in the sea. And the squid collects all the coins. Happy squid. So in the next video, I'm going to expand on this game and show sprite sheets, animations, and talk more about game states, about how to have a menu state, an end state, and a play state, and switching between them. So we can create a full game, have an initial menu where you pick some options and start the game, have a play state where things actually happen, and then the end state as sort of a game over or keeping track of the score at the end. Thanks for watching.